So now we're going to talk about solving quadratic equations through using square roots. Go ahead and take a few moments, set up your notes, quadratic equations, Unit 6A, Homework 4 with the appropriate date, and set up the right-hand side of your papers for any questions, comments, or queries. Make sure you title your notes, Solving Quadratic Equations, Square Roots. So here I have a quadratic equation. Once again, we know it's a quadratic because of our square part of our x. And I have x squared minus 4 equals 0. So when solving using square roots, we want to be able to isolate the x squared term. So I'm going to take my constant and add 4 to both sides to get it on the other side. And that'll give me x squared equals 4. Next, we need to undo the square. And we do that by taking the square root. Now keep in mind, whenever you take the square root of something, you need to show it as a plus and minus square root. And we'll talk about that in just a moment. I know we've mentioned in class, but we'll expand on that some more. And then a square root and a square will undo each other. And the square root of 4 is 2. And we have a plus or minus 2. Now, the reason for that is we can have 2 times 2, which is 4, and we can have a negative 2 times a negative 2, which is also 4. So whenever you take the square root, you must have that plus or minus piece in front of it. Now, we need to go ahead and check our solutions. We have a positive 2 and a negative 2 as a solution. So we're going to take that and plug it into our original equation. Making sure I use parentheses, simplify. And I get 0 equals 0, which does prove true. Let's try the negative 2. Making sure I use parentheses again when I plug in. And it simplifies to 0 equals 0, prove true. So my solution is x equals plus 2 and negative 2. Take a moment to pause copy before continuing on. So let's look at x squared minus 50 equals 0. Once again, we're going to isolate our x squared value by adding 50 to both sides. And that's going to give me x squared equals 50. So next, I want to undo the square, remembering that on my answer side, it's going to be plus or minus the square root of. Now, the square root and the square will cancel each other out, but I need to do the square root of 50. And unfortunately, the square root of 50 is not a perfect square like we had with 4. So this is where I want to come up with all the factors of 50, and I want to pick the set of factors that have a perfect square in it, 2 and 25. And so I'm going to break the square root of 50 down into the square root of 2 times the square root of 25. And the reason I do this is, although I can't do anything with the square root of 2, that's an irrational number, I can simplify the square root of 25, which is 5. So now I can rewrite this, keeping in mind that my solution must be plus or minus, as x equals the plus or minus piece 5 times the square root of 2. Keep in mind, your number without the root goes in front, and your leftover goes at the end. Now, you need to go ahead and check this to prove that your solution is true. So we want to go ahead and take the positive 5 times the square root of 2 and the negative 5 times the square root of 2 and plug it into the original equation. So here I have 5 times the square root of 2 plugged in, make sure it's in parentheses, and I simplify. And I end up with 0 equals 0, which does prove true. Now let's try the negative half. So negative 5 times the square root of 2 in parentheses, simplifying, and I get 0 equals 0, which does prove true. Go ahead and take a moment, pause, copy before continuing on. So let's get a little more involved with our quadratic equations. Here I have a quadratic equation that's in vertex form. Here we have our h and our k. And I want to go ahead and solve for x. Because it's in vertex form, I can go ahead and treat it just the way I've been treating my other pieces. I want to isolate the square term first. So I want to get x minus 5 squared by itself, and I'll do that by adding 100 to both sides. And that's going to give me x minus 5 squared equals 100. Now, next step is I'm going to go ahead and undo my square, keeping in mind that I got to have that plus minus piece. And my square root and square will cancel each other here, leave me with just x minus 5. And the square root of 100, it's a nice, easy, perfect square, is 10. So now I have x minus 5 equals plus or minus 10. Now I just need to get my x by itself by adding 5 to both sides. And that's going to give me x equals 5 plus or minus 10. And I can go ahead and simplify that into 5 plus 10 and 5 minus 10. So the 5 plus 10 is going to give me x equals 15. And the 5 minus 10 will give me x equals negative 5. So I have my roots. I can go ahead and plug them in to check for accuracy. So I'm going to start with 15, plug it into the parentheses, and simplify. And I get 0 equals 0, which does prove true. Next, let's do the negative 5. Okay, I've got it plugged in. Let's simplify. And I get 0 equals 0, which does prove true. Go ahead and take a moment, pause, and copy. Now, for your try it out, I've got 3 different quadratic equations. I'd like you to solve them by taking their square roots, and each one represents the example that we had in our notes. We'll go ahead and go over the answers when you get to class next, and answer any questions or comments that you may have. See you next class.